In merge intervals, our task is to take a 2D array of intervals and return that 2D array where any overlapping intervals have been merged. For example, for the 2D array 1304, we would want to return 04 because that interval would cover both intervals in our input. You can imagine using this idea in the context of a scheduler like Google Calendar. Although this problem may at first seem trivial, we will explain why a naive approach will not work. Let's get started. So our naive approach might be to notice that if the end of one interval is less than the end of another interval, we could go ahead and merge the intervals together. This is mostly correct, but the problem is that we fail to consider how we might merge the starting overlap values as well. Furthermore, how do we know from which position to merge? Do we merge from the left or from the right? Well, the basic issue is that since we didn't sort the list first, we don't have any clear way to know where to start merging. This is why such an approach will fail in some cases. The correct approach is to first sort all the intervals based on their start time, ensuring that we know when the earliest times are and thus can merge going from left to right. We say that if the value of the next interval's start time is less than or equal to the last merged value's end time, they overlap. We then need to see which end time is bigger and use that end time in our newly merged interval. Otherwise, we append the interval to our list. Our final answer has correctly merged any intervals with overlap and has done so both for start times and for end times. Our solution is to first sort our list using a lambda function, where we sort based on the interval's start times. We have a new list name merged and initialize that list with our first interval. Then, looping through the remaining items in our interval, we check to see if the start time of the interval is less than or equal to the end time of the last merge interval. If it is, we should merge this list. We then use as our end time the max of the new interval or the last merge interval. If there is not an overlap, we append this list as is to our merged list. Finally, we can return the merged list. The time complexity of this algorithm is O of n log n because we sort a list. The space complexity of this algorithm is O of n because we store a list of size n and return that list as our answer. We should better understand interval merging, and we can use this understanding on other problems that require interval overlap too. So happy coding, and we'll see you next time.